Yes, student, as I told you earlier, there are few more substances which act as acid and bases. However, they do not release H cation and OH anion. So now the next concept is called Bronsted concept of acids and bases, like the Bronsted acids. Okay, substance which donates H cation, or now the H cation is also known as what? Proton. Why it is also known as proton? It is because you know that in hydrogen neutral atom there is one electron and one proton. If hydrogen atom will lose electron, then will convert into H cation. That means after losing electron, only one proton will remain without electron. Therefore, this is called what? Proton. So, substance which donates H cation or proton in aqueous solution. Okay, two other species. Two other species is called what? Acid. Like HCl when added to water. Now student, HCl is polar molecule and highly polar molecule. Due to this, the H is not satisfied with Cl. Therefore, HCl donates its lone pair. Donates its hydrogen cation. After losing hydrogen cation, now H2O becomes H3O cation. This is called hydronium ion, plus it becomes what? Cl anion. So being HCl is donated proton, therefore this is called Bronsted acid. Getting? Called what? Bronsted acid. Similarly, we are having what? Bronsted base. Now, it is what? Proton donor. So, simply what we can say? Proton acceptor species. Proton acceptor species are called base. But which base? Are called Bronsted base. Isn't it? Like here, in the same reaction, we can see HCl plus H2O. Isn't it? Now, the HCl is donated its proton. That is what? H2O is accepted proton. This is what? Accepted what? Proton. That means now it become Bronsted base. Isn't it? And the same reaction will be there. What? It is become Cl anion plus H3O cation. Isn't it? We can also write here one more reaction of Bronsted base. Okay. How? HCl plus NH3. HCl plus NH3. Now, HCl is donated its H. Therefore, it converted into Cl anion plus NH3 becomes what? NH4 cation after gaining proton. So, this is proton donor. Therefore, this is called what? Bronsted acid. And this is proton acceptor. Therefore, this is called Bronsted base. Isn't it? But can you deal the reverse reaction with it? Like here, again here the cation and anion are there, means highly reactive species. So if H will lose its proton, that is proton donor, then will be considered as acid. But this acid is known as conjugate acid. This is called what? Conjugate acid. and it is accepting proton, therefore it becomes what? Base. But now this base is known as conjugate base. Okay, similarly here it is what? It is Bronsted acid, and this one is Bronsted base. But the similar reaction, H3O is donating its what? Proton, therefore now it becomes being it is donor, therefore acid. But which acid? This is called conjugate acid, and it accepted proton, therefore this is called what? Conjugate base. Isn't it? Similarly, in this reaction we can find the reverse reaction also. This is Bronsted acid, this is Bronsted base. So now the Cl anion, okay, being it is accepting proton, therefore that is called, conjugate what? Base, and this is called what? Conjugate acid. Isn't it? Now between HCl and Cl anion, look at HCl and Cl anion, it is the differ by what? Proton only. Such pairs of species which are differ by H cation is called conjugate pair. Conjugate pair. So now we are having one more terminology. What is this? Conjugate pair. So what is the conjugate pair? Two species which are differ by what? H cation or proton. H cation or proton, called what? Conjugate pair. Called conjugate pair. Okay, so you can write many of such reactions. Okay, here we can write this type of reactions.